Hey everyone, welcome back to Statistics Bio 7, where we make data analysis simple and powerful. In today's, we are diving into Explanatory Factor Analysis or EFA using real physiological data in R. We are not just doing the analysis, we will interpret it, visualize it, and uncover the hidden structure beyond our biological variables. And how to analyze explanatory factor analysis in RStudio. That video already published in our channel. That video link this video description box available. So let's go to the video. What is explanatory factor analysis? EFA is a dimensionality reduction technique. It helps us identify latent factor, hidden variables that explain the patterns among observed variables. Think of it like this. Instead of looking at 10 different physiological measurements separately, EFA helps us summarize them into two or more underlying health indicators. So the dataset and variables for the EFA. For this analysis, we used 10 physiological variables, including systolic and diastolic blood pressure, glucose, cholesterol, BMI, waist circumference, triglycerides, HDL, LDL, and heart rates. The dataset contains 20 individuals, and while that's a small samples, the results are quite strong. The table for the assumption checks, the test result and interpretations. So the KMO, the result for the 0.89, the excellent samples adequately for EFA, and Bartlett's test X square value 545.31, the p-value 0.001. The significant variable or correlated engage for factor analysis. The sample size is 20, small but sufficient for the 10 variables given the strong communicators and high KMO. Before doing EFA, we checked some important assumptions. The Kaiser-Meyer-Vulkan KMO test given as an overall value of 0.89, that's considered excellent. The Bartlett's test of specificity was highly significant, indicating our variables are correlated in case to the justified factor analysis. So the next one table for the rotate factor loadings table, the 10 variable for the physiological parameters, the systolic blood pressure, diastolic blood pressure, and glucose, cholesterol, BMI, waist circumference, heart rate, triglycerides, HDL, and LDL. For the value present for the factor 1, 2, and 3, community H square and uniqueness U square, the value present for the rotate factor loadings table. The factor interpretations. The factor 1 shows a high loading on triglycerides, LDL, cholesterol, and an inverse loading on HDL. This factor likely represents cardiometabolic risk. The factor 2, the load strongly on BMI, waist circumference, blood pressure, and glucose. This one reflects a body composition and circulatory functions. The basically how weight and metabolisms affect the cardiovascular health. The factor 3 has more mixed loadings across the heart rate, LDL, and glucose. We interpret this as a measure of metabolic stress or homeostasis. The table for the model fit interactions. The fit measure value and interpretations. RMSEA, the value 0.072. The good fit below for 0.08. 2K Slovene index test 0.983. The excellent fit for the higher 0.90. The high square likelihood, the value for the 20.83, the degrees of freedom 18 and p-value 0.29, not significant, model fit well. The RMS or the value 0, the perfect residual fit. The fit of this model is excellent. The 2K Lewis index was 0.983. The RMSEA was just 0.072. Well below the 0.08 cutoff, and all residuals were near 0. So yes, our factor model it's the data very well even with a small sample size. The figure 1, the parallel analysis of scatter plot for determining the optimal number of factors. So this is for the parallel analysis scatter plot. The parallel analysis indicate that 3 factor solid be retained for the data set. This conclusion is drawn by comparing the actual eigenvalues, the blue line with the triangle markers, to those obtained from the randomly generated dataset, the red dash lines. Only the first 3 factor had eigenvalues generated than the corresponding simulated value, suggesting these are meaningful and explain more variations than explained by the chance. So the figure 2, path diagram illustrating the factor loading after Oblimin the rotations. So 3 structure revealed 3 principles latent the constructs. The factor 1, PA1, the strongly loading on triglyceride, the value for 0.7, and HDL, diastolic blood pressure, cholesterol also the value 0.7, the HDL only the minus 0.7, and LDL 0.6. This factor may be represent a cardiometabolic risk compound like lipid profile and blood pressure indicators. The factor 2, PA2, dominant by the BMI 0.7, circumference 0.7, glucose 0.6 and systolic blood pressure 0.6, indicating a potential of obesity glucose regulations dimensions. The factor 3, the PA3, the heart rate, the value 0.6, the interpret as a cardiovascular regulations factor. Those grouping align with the physiological meaningful clusters, reinforcing consider the validity. So the conclusion of the explanatory factor analysis. The explanatory factor analysis of 10 physiological variables revealed a clear 3-factor structure accounting for the underlying latent dimensions of cardiometabolic risk, obesity glucose regulations, and cardiovascular functions. The factor loading were strong and constant within the each domain, suggesting that the measured variable cluster meaningful according to their physiological relationships. This result highlighted the multidimensional nature of metabolic and cardiovascular health, offering a robust framework for future clinical and epidemiological analysis involving the complex health indicators. If you found this helpful, don't forget to like this video, subscribe to the Statistics Bio 7 and turn on notification for the more the tutorial likes one. If you like this video, join to our channel membership and Want the full code of the R? Check the description box on this video. Thank you for watching this video.